now is a very good time to learn more about value types, and it's a good thing because we have Henning Schwentner here with us. Welcome, Henning.
And thank you again for the warm welcome, and welcome from myself to you to our session, Java Value Types, the next big thing for Java. Here on the Jfokus 2017, sorry, at the waterfront in the beautiful city of Stockholm, or as Twitter says, hashtag Jfokus. And I know after lunch, we are all a bit tired, so I want to do a little exercise with all of you. And for that, please stand up, everybody. Great, thank you. And now, please come to the front and to the middle, so we have a compact, condensed audience. And we have enough space for everybody. Okay. This is more fun when the audience is smaller. Okay. Okay, then please take your seat. Thank you very much. Okay. So, my name is Henning Schwentner. I think that's a bit hard to pronounce, but you can just say Henning, that's easier. I'm, of course, in the social media, Twitter, Snapchat, and all this stuff. And there you can find me at H. Schwentner, okay. Maybe just look for Henning Schwentner. And like I think most of you, I've studied computer science in the University of Hamburg. I have a color problem, I can see now. I like good food. I like good football. That's more hard to get if you're not German. And I like yoga. And I'm a proud dad. And and actually, my children are not blue in the face. Okay, and of course, I'm not here to talk about family, I'm here to talk about work and about Arbeit, as we say in German. And I work as a consultant, I work as an architect, as a coach, mostly coach for German teams. But deep in my heart, first of all, I am a developer, I'm a programmer. And typically, I hack in Java or C#, but I even spend a lot of time with SAP hacking ABAP, or ABAP as we say in German. I'm working in Hamburg in Germany for a company that's called WPS, Workplace Solutions, or Whiskey Papa Sierra. Whiskey Papa Sierra. And we're a company of 75 architects and developers and consultants. And yeah, we're also not blue in the face. Should I give it a try and put up the cable? Okay, and our motto is enjoyable business software. Okay, what does that mean? In German, business software, die Spaß macht. And if you look at a classical workplace where you use software, it looks like this. You have a keyboard, you have a mouse, everything is gray. But nowadays, the world is not so gray anymore. We have smartphones, we have tablets, and there are even bigger touch devices, these so-called multi-touch tables. And the nice thing about this size is, when you have this size, multi-touch can be used for multi-user. So you can stand together around such a table and work together. So that's what we do, build software for such things. And the next thing to come, I think, even to the workplace, is augmented reality. Okay, that's why we call it enjoyable business software. And that's nice for the users if they enjoy it, but we as developers want to enjoy ourselves also, of course. And I think we will have more fun, more joy with Java, with value types. Why is that? That I will tell you later. I myself am also not blue in the face, and I have no affiliation with Oracle. So everything I will tell you about the value types, how they are implemented in Java, I have learned from the outside of Oracle, which means from the internet, of course. But here on the Jfokus, you've already seen some of the inventors, especially one of the inventors of Java value types from Oracle is here. Mark Reinhold, you heard him in the keynote at this very stage. And so I'm a bit scared. Mark tells me afterward, everything you sell is complete nonsense. But I will then just say, that's not nonsense, that's alternative facts. So let's hope that will not happen. But if he does, you can later go to Mark's session, ask the architects, where you can see all the details. I will not tell you. Okay. But first, I will give you my view, my impression of value types and why I think that's a great thing. Java is a programming language, and we will look at some code in this talk, but I think that should be okay since this is a Java conference. But for those people who say, oh, that's too technical for me, it's after lunch, this is the Wi-Fi data. But the Wi-Fi does not work so stable, so I think most of you will have to follow me. So let's start with value types for Java. Okay, how is it that we are talking about this today? I first heard about the Java implementation of value types 2 years ago when I was at JAX. That's another conference on Java, a German conference on Java. There also was a keynote, also from an Oracle guy, also from one of the inventors of value types, but not Mark Reinhold, but Brian Gertz. And he told us then what was then new in Java 8, because it just had arrived then. Java 8, things like lambdas, stream API, Java util optional, and all this stuff. But he also gave an outlook to what would come with the next versions. So with Java 9, of course, modules, as we all heard in the morning, with Project Jigsaw. And with Java 10, he said, the next big thing for Java is value types. Okay, it was a bit like today, where we had this keynote about Java 9, and then this expert Java 8, and now Java 10 with value types. Okay, so when I heard that Java would get value types, I was very happy. Why? Because I think values on the one hand and objects on the other hand are two fundamentally different concepts. And I think it's a good idea to have them both in the programming language you're working with. But this distinction between value on the one hand and object on the other hand is not only a technical distinction, something that we as developers do, but also, and more important, a distinction that is main in the domain. It is main from the business. And since software is a model from the real world, from the domain, or a reflection of the domain it belongs to, I think we can build better software and better understandable software when we can express values and value types coming from the domain directly in the programming language. And this is really a strange color. Okay, what is the current state in Java? As we all know, Java is an object-oriented language. And that means objects are at its core. So what is an object, or what does make an object? An object has an identity, and it exists in time. That means it is created, and then it can change its state, maybe from blossom to fruit. And finally, it will be destroyed, and then comes the garbage collection and cleans up. Values, on the other hand, they don't have an identity. They are abstractions, and they somewhat exist out of time. They are immutable. They do not change their state. Okay? That sounds maybe a little bit too abstract. Let's look at an example. Sorry. And when we look at all the couples in the world, or the pairs in the world, then maybe an abstraction of this, of all these couples, is the concept two. So, and if then a couple chooses to separate from each other, or to get divorced, then the concept two, the abstraction two, is not bothered from that. And even if all couples in the world get separated, that still leaves the concept, the abstraction two, unbothered. It's still there. That is the philosophical view, but most of us are not philosophers. We are programmers. What's our view on this? In Java, objects can be created from classes. So we define classes as programmers, and then we can make objects. So the class is the form with which we can cut out the cookies. At least if you think about software as a cookie dough. Then we have the class here and the objects there. And the objects can change their state, and they have an identity, and finally they can be destroyed. And the identity of these objects is modeled with a reference, or more technically, with a memory address of this object. That means these two variables are equal, so the method equal will return true, because they have the same value behind it. But they are not identical, because they do not have the same reference. And in this case, these variables are equal and identical, so not only the method equals, but also the operator equals equals will return true. Okay, an interesting question is, where does an object actually live? So the answer is objects live on the heap, but what does that mean? When we look into a process, that means a running program, we have basically two areas in the memory. The one is the stack or call stack, and the other is the heap. The stack works like this. When we look at a program in execution, a process, it is at any given time at exactly one point in the program, if we're not talking multi-threaded, if you think about single-threaded. And when at this point in the code a method is called, the parameters for this method call are pushed on the top of the stack. That's why it's called a stack, because we push something on it. And also there's memory reserved for the local variables of the called method. And then the called method can change these variables and work with them. And when the method is finished, it returns, and the parameters, the local variables, are popped from the stack, and the return value is pushed on the stack, and we're back in the calling method. Okay, the nice thing about this is that the required memory for this method call can be determined at compile time. And it means memory management is easy, because we call the method, we know all the memory, then we come back and we know this memory can be cleaned up. On the other hand, the heap is just a big area of unordered memory from which we can reserve chunks in the size we need. And how much we really need, we know only at runtime. And the memory management is not so easy. Either you have to do it yourself if you're in C or C++, or in Java, we're lucky we have the garbage collector. He will do this for us. But it takes time, of course, for the garbage collector to clean up. So it's not bad if things can be on the core stack. Okay, now we know an object lives on the heap. What's about values? Values, they lie directly in the variables themselves. So we don't have references, we have the values themselves. Which means these two variables are equal, and as we said, values don't have identity, so we cannot compare the identity. But we all know not only the method equals will return true, but also the equals operator on these variables. Okay, values can live on the core stack, and we heard that's something good. Or inside of the objects that they are defined in. It's also good, because then we don't have the effort to dereference and to come to the real value. In the current Java we have now, until Java 8, and it will be the same in Java 9, we only have 8 types of values. That's the primitive types that are built into Java. That's int, double, boolean, float. And what are the other 4? Short, byte, character, and long. Great. Not everybody is sleeping. What we do not have, or what we cannot have in Java until 9, is user-defined value types. So we don't have technical types like unsigned or complex, and we don't have domain value types like a bank account number, or IBAN, or a postcode, or an amount of money. What we can do is build ourselves a crutch, a so-called value-based class. Okay, what's that? That's an object type with value semantics. So we build a type, we build a class that has only final fields and no state-changing methods, only methods that return a state. And we implement the equals method so that it does not depend on the identity, that it does not depend on the reference, only on the fields. Okay. Then we have objects that pretty much behave like values, but really aren't values. So since we have still something like this, we have these things here which are immutable, but which have some kind of identity. Not an identity like in the sense of the equals method, but of course in the sense of the equals operator. And of course, the instance of value-based classes have to exist on the heap, because they are reference types, of course. And so we can't pass them by value, we can only pass them by reference. And when we want to access the value, we have to spend the effort of the dereferencing. Also, we need more memory, because the reference itself needs more memory. And that is especially true and especially a problem for small things. And values typically are small things. So for this, we need twice the memory than for this. This is an int, and this is the reference to this int. Something like an instance of the integer class. Okay. We would maybe rather have something like this, value directly in the variable. And it gets worse when we don't just have one thing, but an array of things. So let's look at an example again. What's an int array? In an int array, the values lay nicely one after the other in the memory. An object array, on the other hand, isn't really an object array. It's an array of references to object instances. So we have something like this, an array of references. And when we look into it, of course, the objects typically do not lie in the heap after each other nicely, but somewhere in the heap. And when we iterate over such an array, we have to look at each reference, dereference it, look at somewhere into the heap, and then we come back and come to the next object. You know what I mean. Okay. So now we've seen some of the problems, of the challenges. What is the answer now from the Java team? The answer is, let's make value types, let's make user-defined value types first-class citizens in the language. And let's make a project that we call, with a fancy name, let's make Project Valhalla. And they built this project, and they gave it a war cry, works like an int, codes like a class. Okay. Another example. Let's imagine a coordinate system. Then a point in this coordinate system is a value with two fields, something like this, x and y. And how would this look like in Java 10 with value types? So I'm going to show you a bit of code, but beware, this is work in progress. So there is no real syntax yet, only an ugly strawman syntax. And that's intentionally ugly, so nobody would think that's the way it will finally be. Okay, the definition of a value type will then look like this. So we will have a type point, a class point, which we will mark as a value type with underscore underscore by value. There you can see the strawman, of course. Something like this, underscore underscore by value. Then, of course, the fields would have to be final, and they have to be initialized in the constructor because they are final. And equals has to be overwritten so that it does not depend on identity, only on the fields. And the type itself has also to be final. Why is that? That's for technical reasons. Because since we want to have stack objects, things that can live on the stack, we have to know the memory, or the required memory, at compile time. And if we could derive types from this type, then the derived type, for example, a 3D point, could add another field, like the z-axis, and then it wouldn't work on the stack anymore, because on the stack, we had compiled only place for two integers for the x and the y. Okay, so they have to be final as well. So then the whole value type point looks like this. And I think that pretty much codes like a class. And how about the other side of the war cry? Works like an int. Is that also right? When we create an instance of this type, we would do it like this. Point p equals make value for 7. And make value is, of course, again, the strawman syntax. And there is discussion, what will make value be? The first idea is, let's do it with new. New point, then it's the same as we do with objects. But it's somehow misleading, because traditionally, new means reserve memory on the heap. That's the inheritance from C++. So another idea is, let's just do this. Point P is 0.47. Or even, let's do this. Why be so verbose? Okay. I don't know what it will finally be. So, when we have this, how would it look like in the memory? Instead of this, with a value-based class where we have a reference here and the data itself on the heap, we could have something like this. So the value type, the value of the value type itself could be in the variable. And it does not have to be on the heap. It can be on the call stack. And we will save memory. And the effect of memory saving is even bigger when you think about that most systems today are 64-bit systems, and that means we have references of 64 bits for and 32 bits for these two integers. So we have this, and we save this, half of the memory. And we save the effort for the dereferencing when we have this. Okay. As we know, identity does not play a role for value types. So we want the operators equals equals and not equals, or exclamation mark equals, to work as intended. So they will be implemented that they call the equals method we defined in the value type. So we can use equals equals and not equals as we would usually do. And they behave as one would usually expect. Okay. Another interesting thing is the default value. For reference types, the default value is easy, that's null. But since value types are value types and not reference types, we need another default value because they cannot be null. And the idea is that you say, okay, value types are in the end made of primitive types, of built-in types, and these built-in types have also default values. For example, the default value for integer is 0, or the default value for Boolean is false. And let's say the default values for user-defined value types are the recursive initialized values. Okay. At this time of the talk, I should take a look at the watch, but it's okay. We already had 160 slides. Not really, it's 260 slides now. So what else is there? An interesting question is, what will be with generics and value objects? So, of course, you want to have something like this, list point. And then there's the question with type erasure. And when we're lucky, we will even get something like this, finally, list of int. We don't have this at this time. We only can have list of integer, the reference type. So we have a reference to the list, and the list has an array of integers, of references to integer objects which have an integer inside of them. That's not what we want. We want integers directly in the list without boxing. And talking about boxing, an open question is also, what does this mean, list point? Does this mean the user-defined value type point, or is it the boxed type point we will also have automatically, as we have them for the built-in value types? Okay. So let's also have a look left and right. How is it in other languages? For example, in C++. In C++, you can choose for your variables, shall they lie on the stack or shall they lie on the heap? And that independently if they are values or objects. Okay. That's C++. So you can declare a point in C++ like this, and that's a stack variable. Beware, In Java, this is a heap variable. In C++ is a stack variable. And then you can assign a value like this. And then you have something like this on the stack. You can even create it as a heap variable with a pointer, with this asterisk. Then it lives on the heap. And you can assign it like this. And there you see, that's why C++ invented the new operator, because their memory has to be reserved. And then you have this. Okay. And then there's a thing called references in C++ as well, but I won't go into detail with this. That's in C++. In C#, we have a thing called structs, or they are also sometimes called value types. And they are also not reference types, so they differentiate between value types and reference types. And they can be on the stack as well, and can be directly in this memory, in the variable, and don't have to be on the heap, can be on the stack. And they also have no inheritance for the same technical reason, of course. But, and that's a bit strange, they have mutable state. So they can change their state over time. So that's good try, but not as good as I would wish for a real value type. And they have another interesting concept of nullable. As we heard, structs or value types cannot be null. And so they invented another type, which is a box around a value type, which then can be null. That's what we do in C#. Okay. So now I talked a lot about technology, and that's okay, because we are technicians, we're programmers. But beware the blue sign. Software is not an end in itself. That we must never forget. We do not build software for technical beauty alone. This is the Transrapid from Germany, a technically beautiful thing which never made it to production. And that's not what we want. What we want is to aim at our goal. And what is our goal? What is the means of software? What is the end of software? That's to support our users with their work. So this is the one that's important. The person that's sitting in front of our software. And to do this, to support our users, it's a good idea to implement a domain model with rich domain behavior in the software. And what we do not want is an anemic domain model. And what can help us to build a behavior-rich domain model is domain-driven design, or especially, in this case, the tactical design of the DDD. And one of the building blocks in DDD is the value object. It's quite a strange name, I think, because a thing can, in my opinion, either be a value or an object, and value object is some kind of contradiction, but Eric Evans called it like this, the value object. And I think a better name for it is domain value, because with value objects, with domain values, we model concepts from the domain that are values. Things like postal code, bank account number, IATA code, GPS coordinate, container number. And these things that are values are part of the ubiquitous language. Ubiquitous language, that's also a strange name. That's a name for the language we, as the developers, have together with our domain expert. The idea is that we can have things that are like values in the domain, and we want to talk about them, and then we create them as value objects. So when we look at an example in code, when we look at a bank account, like we all have, then maybe a minimal implementation can look like this. It will have a balance, and we can withdraw money from this account. That's nice. Okay. And then there's, of course, some other stuff. But if we look at this in total, what is the amount in? Is it in Swedish crowns? Is it in euro? We don't know. So we would probably want something like this, a currency. So then we could check in the withdraw method that the currency of the amount equals the currency of this account. Account. That works better in German. But probably we do not want to only withdraw money because the money will be empty sometime. We also want to deposit money on the account, and so we add a new method, deposit. But then we have to do this check twice because we can withdraw money only in the right currency and we can deposit money only in the right currency. So wouldn't it be better if we had our own type for this? An amount type, something like this, which is, of course, a value-based class. So we have final fields, we have a constructor in which these final fields are initialized. We would have an equals method. I don't show it because we don't have the space. And then it can have an add method, and this add method can check for the correct currency in one place, in this amount class, where it belongs. And it does not have to be scattered through all the system. And we can have a currency type as well. We don't have to use string for currency. But we won't look at this because we don't have the time here. When we have this amount, we can then build our account class nice and easy, like this. So we don't need these anemic ints anymore, or these anemic strings. We can have real domain types like amount, which is a value type, or a value-based type. And this code is better understandable and expresses the domain much better than it did before. And we can look at the things we really want to do with an account. For example, not withdrawing more money than we have on the account. But then somebody says, oh, these amount objects, they're taking too much memory. We don't want all those memories. We have the garbage collection. This is imperformant. And then we have to go back to this old system, and then we have an dynamic domain model. And that is why I think that is a great idea to put value types into Java, which version 10 or 11 or whenever. Not because that's a nice technical feature, but because we can express our domain model, much better when we have things like value type. Okay, we could then do this. Public __ by value class amount. And we see the strawman again. And then we can have both, eat the cake and have it. Performance and domain, rich behavior domain model. Okay, coming to the end of the talk. As you have seen, there's a lot of under construction in the Java system. And you can build domain values at this time already, but not performance. And so since this is in construction and you're interested in more, what's the further reading? Project Valhalla is the name, with V like value. And it has also its own Wikipedia article And another thing is, as I said, go to the session of Mark Reinhold this afternoon. Maybe there will be some more information about this. And another thing I would recommend is that you read this book, Domain-Driven Design, which is called The Big Blue Book, actually. And it's called big because it's quite thick. And last year, a new book came out. It's called Domain-Driven Design Distilled. And the good thing about it, it's much thinner. So if you don't have the time, give it a try. Domain-Driven Design Distilled by Vaughan Vernon. It's only, thank you. It's only 100 pages or 120 pages. Read. Okay. If you're more the hands-on guy, you can book me for a workshop on domain-driven design. And talking about advertisement, think about doing something good. For example, making a blood donation. Yeah, at the end, please give feedback to the conference or to me via mail or via Twitter. I thank you very much, and I have come to an end. Thank you.